Good day, ladies and gentlemen. This is Khazar University Mechanical Engineering Design class, and today we will design a valve. And so in exam we will have to draw the parts. So I will give you a part, and you will draw the shop drawing, the 2D drawing of that part. And in this class I'm planning to finish the valve design, and after valve design I'll draw some parts so you can prepare for the exam. So gate valve, I have already drawn the body part of the gate valve, and now I am planning to let's start from simple parts. Let's say this glass. Let's make a shop drawing of the glass. So this is the top view of the glass. The top view, as you see, it's the top view. The scale is 2:1, so it's 2 times bigger than the cup itself. And I make a cross section AA. This is AA. I cut it from the middle and I draw its view from the cut from the middle. I put a axis symmetric line in between, so it means it's round. I put a center line for the cup top view as well. All it matters is to give as much information as needed in order to produce a cup. So for producing it, the guy in the shop floor has to know the thickness of the cup. So you give this thickness 5 millimeter. You don't write millimeters, just give it 5. This thickness 10. This outer diameter is, let's say, it's like 70. Inner diameter, let's say the bottom inner diameter, let's say it's 60. So yeah, it should be 50, so 60 is too much. Okay, so from wall thickness we will know how much will be the inner diameter of the glass. And yeah, this is for glass, very simple. And these stripes here, they mean it's a metal. So for metal you should give surface roughness. So of course the glass is from glass material, the cup is from glass material, but we will produce it from metal, and everything you do will be from metal. So 6.3 will be the surface roughness for the finishing this glass. And of course, in order to produce this glass, you need special fixtures which will hold it in order to machine it. Yeah, that was a glass, very simple. Let's do something different. Let's pick some other object. Let's pick this Canon charger. So, very simple. Front view. That's front view. Top view. Do you think there is need for side view? Of course there is. Top view, side view, the front view. Yeah. So, from this perspective, we put this here. From this perspective, we put dashed lines. Dashed lines mean it's on the opposite side. The sketch is in opposite side. Solid line means it's what we see. Dashed lines means which we cannot see from this view. We can see it from the opposite view, or it's internal. So here we do this. Yeah. Let me show you more details. So this is here. This inside there is a dashed lines is here, and this here is here. Of course, this battery charger consists of two parts, which was molded by mold injection. But for sake of simplicity, I have drawn it as one part, and since it's educational purposes, I think this assumption will be acceptable. So, now imagine you are a technician in a shop, you're a machining guy, and you received a CAD drawing, a shop drawing from a student. Which dimensions you need to know in order to machine it? Very simple. This. Let's say it's 40, it's 60. Then you need inner dimension 20. This dimension 30. So even if you make very inexact drawing, your dimensions have to be exact. So don't think that I just write these numbers from my head. I actually measured them, and as you can see, it's 60 millimeters as I have written there. Yeah, so 60, 80, 35, 50. Exact dimensions. This height is 10 millimeters, so this is 10, this is 25, as you know this is also 25, so that's all dimensions required in order to produce this part. Yeah, of course it's not understandable in small drawing. I'm in large, so it's 1:1. Yeah, its scale is 1:1, and I'll make a bigger scale for you, 2:1. So 160. Good. Yeah, 120. Exactly. 160. 120. So this is this, but with scale of 2:1. Yeah. When you give small scale stuff, you will get complaint like it's small, I can't understand. But when you make it more clear, people actually appreciate it. So 7. What, 7, 10. So we didn't put this one, 8. Very important, we didn't put it there, we made a mistake. Good, good to know. So this is 50. This is 35. This is 60. This is 80. Excellent. So everything is shown for front view. Now what? Now I think, yeah, we will do the next. We draw the right view. Good. We measure it 25, 20, so 40. 40, something like that. So, if you look from this perspective, this is it. The dashed part shows we can see from this perspective, we can see it from the other side. And we give dimension like 20 millimeters. This dimension we know. We give it 80, but with an asterisk. Meaning that it's giving as for information. Yeah. Other thing is, I think that is the other thing is this one. So it's 15 millimeters. 15, yeah. So apart from it, you should put tolerances. You should write here like the tolerance, IT tolerance, IT, let's say 14 plus minus IT 14 divided by 2. So the tolerance gives an idea of how much plus minus deflection error is allowed to be made during machining. For surface finish, I'll put 6.3. 6.3 is the best number to not get any problem with the machinist, because it's very easy to finish with the modern CNC and NC machines. So you put the tolerance, apart from you write that this asterisk means for information. Apart from asterisks, you may write something about welding, but there is no welding in this geometry, so you can omit it. Yeah, I think this is enough for giving you an idea what to expect in your final exam. So I'll give you some geometries, the 3D models, and I'll ask you to transfer them into a shop drawing, and I will evaluate by the machinability. So if I see that there are missing dimensions, I will cut your scores, because if you give it to shop for machining and they find missing dimensions, they call you, you tell them, you lose time in your company, and time is money. So try to be as explicit as possible. So I will make one exam for both classes. The exam will be about mechanical engineering design and CAD. I will give you your project, the project you did, the same thing I will give you at the exam, but with technical parameters. You will have to make engineering calculations, you will have to make the list of materials you need, you will have to give me data about its design, and for CAD part you will have to draw shop drawings of it for me. So it will be like, let's say it will be done by hand or by a software. I really don't mind which way you will choose. It's both okay, both ways are okay for me. I will continue valve, about valve on software, because drawing on the whiteboard seems to be cumbersome procedure for this, so it's easier to do it in a digital manner.